The first part of the math section that we really cover for the ACT is number and quantity, and that's going to take us up through this spot right here, which is algebra and functions. So this section right here is all about number and quantity. Basic examples, you have to be able to look at decimals and understand how they compare. What is the smallest decimal here? Yeah, the last one, exactly, and that's less than, what's the next one going to be then? Yeah, the 101. So we've got 0.001 is less than 0.101, which is less than, we got the 0.11 now, just in the 1.01. Okay, should be able to compare them. Should be able to compare fractions. Notice that these fractions do not have common denominators. If you want to compare them, sometimes it's easier to write them as a mixed number. For example, 100 over 99 is 1 and 1/99. Whereas 5/4 is 1 and 1/4. 9/8 is 1 and 1/8. 3/2 is 1 and 1/2. Now that you write as a mixed number, it's easy to see that 100 over 99 is your smallest fraction. And then the next one will be 9 over 8. And the next one will be 5 over 4. And finally then 3 over 2. Sometimes it's most helpful to write it as a decimal. What is 25% as a decimal? 0.25. What is 1/5 as a decimal? 0.2. And then we have 0.3 on the end there. So you can see that the smallest one is going to be 1/5, which is less than 25%, which is less than 0.3. The last one, we don't have decimals. We have some fractions in there, but we can approximate these values. So for example, 5/3 is 1 and 2/3. So you know it's between 1 and 2. The square root of 7 is between the numbers 2 and 3, because the square root of 4 is 2 and the square root of 9 is 3. So the smallest one here will be 5/3, and that is less than the square root of 7, which is less than 3 and 1/3. Being able to compare your decimals and your fractions, a basic skill that hopefully we remember and we need to be able to apply. Other things that they want you to be able to do in number sense in order to score some points, to be able to add, multiply matrices. If you add matrices, this matrix here happens to be a 3x2 matrix. When we go ahead and we decide the size of a matrix, we always think of the rows by the columns. So 3 rows by 2 columns. They are both 3x2s, which means I can add them together. And when you add them, you just add the corresponding entries. 1 plus 5 is 6. -1 plus 3 is 2. So on and so forth. Add up the corresponding entries and be done with it. No big deal, right? If you're asked to multiply by a scalar, we talk about that number out in front as a scalar. It just scales it either larger or smaller. We get the same size matrix. It's a 3x1, and we get a 5, a 0, and a -20. We just simply multiply that through. But suppose they ask you to multiply two matrices. They ask you to multiply. This matrix here is a 1 row by 3 column matrix, and the other one is 3 rows by 2 columns. And the question is, are they compatible? Can we multiply the two together?
Yes.
Why?
Because the second of the first one and the first of the second one is the same.
Very good. These tell us that they are compatible. If these numbers on the inside match, then they are compatible. On the outside, that tells us the new size of the matrix. So this is going to produce a 1 by 2 matrix. So 1 row and 2 columns. We're just going to have these 2 entries. The way that you multiply a matrix is you go ahead and you take this row and you simply just lay it on top of this column, and then you multiply the corresponding entries. So if we lay it on top of it, we have 1 times 3 is 3. We have 0 times -1 is 0. And we have 2 times 0 is 0. You add those together and you get 3. We take the 1, the 0, and the 2, and we lay it on top of 0, 1, and 4. 1 times 0 is 0, 0 times 1 is 0, and 2 times 4 is 8. So we get 8 out of that deal. So 3, 8 is the new matrix. Now, there is other material on the ACT sometimes, and you might be asked to find the determinant of the matrix. That'll be for a higher score in the 33 through 36s. We can maybe talk about that at a different time. Other things you need to be able to do to get those top points are be able to deal with complex numbers. You should be able to add them together, like 4 plus 2i plus 3 minus I. Just simply combine your like terms together, we get a 7, and we get a plus I. You should also be able to multiply them. Go ahead and multiply 2i times negative 7i. Check with the person next to you, see what you get. I multiplied and I got a negative 14i squared. I recognize I squared is negative 1 times that negative 14 is a positive 14. Okay. Simplify the next two. I to the 51st power. This was a little bit challenging. The other groups really struggled with this one. Does anybody here remember how we do I to the 51st without multiplying out 51 times?
Just negative 1. Or if it's odd or even.
Odd and even does matter. There's one more trick that we have to pull in order to make that work, and that's I'm going to write it as I to the 50th times I. Everybody agree I to the 51st is I to the 50th times I? And what we know something important about is not necessarily I, but rather I squared. So I to the 50th is I squared to the 25th power. Now that I've written it so that there's an I squared, now I can really do some damage to this problem. What is I squared? Negative 1. And negative 1 to the 25th, as you said, Nevaeh, it's odd, and an odd number to, or I'm sorry, a negative number to an odd power is going to produce
negative.
A negative. So negative times I is just negative I. If you're dividing by I, just simply multiply the top and bottom by I, and we get negative 4i over I squared. Notice that I squared is negative 1, so that will cancel off the negatives, and we get 4i. So being able to deal with those is important. Locating square roots and understanding what integers are they between, something you'll be asked to do as well. Square root of 4 and square root of 9 is going to be what makes up the square root of 7. It sits between those. So square root of 7 will sit between 2 and 3. Square root of 63 sits between root of 64 and root of 49. So it sits between 7 and 8. Some of these you're like, well, why wouldn't I just use my calculator for this? Some of this they'll embed in a question, and you want to have that reference so you can do it quickly without turning to your calculator. Remember, it is timed. What is your anticipation right now? Do you think you'll have enough time, more than enough time, or not enough time in the ACT? What's your thought right now? Anybody want to share where you think you'd be at?
Not enough.
Okay. My guess is that as I look at this group right now, I would say that I think we'd be about a third in each direction. About a third would say I just barely don't have enough. About a third of you would be just right. And it would be a third of you, you'll have some extra time to go back and check. Are you penalized for guessing? Absolutely not. Guess every bubble. Fill in every bubble. Not A, B, C, D, and E for each question, but one guess per question. Last thing you're going to be asked to do, and they do like these problems, is apply your rational exponents. What does it mean to do 64 to the 1/2 power? Yeah, that's the square root of 64, which is 8. 8 to the 2/3, that means the cubed root of 8 squared. So remember, what's in the denominator for that fraction comes out to the index. 8 squared is 64. What's the cubed root of 64? It is 4. 9 to the a over b. Again, the b comes out as the index, and it's 9 to the a power. Okay. I promise that you'll have multiple questions on the ACT involving proportions, one of the most common things that are set up. And again, the first time you encountered this was really kind of in your 7th grade spot. I made pizza last night. It was delicious. I put pepperoni, Canadian bacon, and Italian sausage on mine, and I loved it. I don't know what you put on yours, but see if you can do this problem. And please write your answer as a mixed number, meaning A and B over C. So how many cups of flour would you need? See if you can figure it out. Go. Okay, how I set this up is I always take the flour and put it over the number of pizzas. You can switch it up and that's fine, but this just helps me stay organized in my work. The amount of flour is 5 cups. It's going to produce 4 pizzas. We're going to set that equal to 7 pizzas, and we're wondering how much flour. As you cross multiply, you get 35 is equal to 4F. And then you divide by 4, and you should get the amount of flour needed is 8 3/4 cups. 8 3/4 cups of flour. Okay? Proportions will come all the time. See if you can do the next one without actually using your calculator. John pays $25 for his meal. He desires to leave 15% tip. Hint, think about 10% and think about 5%. See if you can come up with this total amount for his meal that he's going to pay. Okay? Oh. 30 seconds, look at that. He's leaving a 15% tip. If he left 10% tip, that would be $2.50. So if 10% is $2.50, what would 5% be? $1.25. That means the total tip is $3.75. Added on top of that, it would be $28.75 is going to be the total for his meal. So again, figuring out some of those pieces, you don't necessarily have to do them mentally because you see your calculator, but it does help you out sometimes. A coat that was $62 is marked down 20%. What's the cost of the coat after markdown? So we want to figure out 20% of $62. And so if we multiply 0.2 times 62, we get $12.40. Is that my final answer? No, that's the amount that it's marked down. So we subtract that from the 62 and we get $49.60. Now that one's not that bad. The next one's a little bit more challenging. It says a coat is marked down 40% and ends up at 80 bucks. What was the original cost of the coat? The key to this type of a problem, I'm going to show you how to set it up in an algebraic way, but is to recognize it's marked down 40%. So $80 is actually what percent of the original value? This is 60% of the original value, isn't it? So what I'm saying is 60% of the original value, so the original cost, is equal to $80. So if you had that type of equation, 60% times C is equal to 80, or 0.6 C is equal to 80, you would simply just divide both sides by 0.6, and you would get the original cost is $133.33. You should be able to translate algebraically words into symbols and back and forth. What does it mean if it says the product of 9 and x? How would we write that? 9x. How about the difference of x from y? Yes, it is y minus x because the x is being taken from the y. 22 less than w. W minus 22. The quotient of 9 and the sum of x and y. What does quotient mean? Division. So 9 over x plus y. Okay? I always see a problem of what I refer to as linear growth. This is a great situation. Don walks dogs, receives $5 for the first 10 minutes, $2 for each 10 minutes after that. If he receives $17, how much time did he spend walking the dog? See if you could quick do that problem. I'm sorry. This is Kevin. Hello? Fine, and you?
And it may give you some better access to things like dental, vision, hearing, and over-the-counter benefits. Now, these benefits aren't automatically given, so we're calling to make sure that you're actually getting everything that you are entitled to. There's also an additional benefit where you may qualify to get up to $148 a month as cash back. Now, that's through your Social Security, depending on your income. Now, I believe you do have Medicare Part A and B, correct?
No, I'm only 45 years old.
So your age is above 65, right?
No, 45 is less than 65.
Oh, the robots. I'm always wondering what it's like to be the person on the other end. You know what I mean? Whatever. What'd you get?
70 minutes.
70?
An hour and 10 minutes.
I got 6.
I got 6 too.
Because what I did is I said 17 is equal to 5 plus 2 times the number of minutes. So I subtracted 5, I got 12 is equal to 2m, and I divided by 2, and I said so 6 is equal to m.
Wouldn't it be 16? Because it wouldn't be. Oh wait,
You have to add the first
add the
10
10
minutes,
minutes.
Oh, so it's 10-minute intervals. So it's 6 10-minute intervals, isn't it? So this isn't 6, this is 60. And then you've got the first 10 minutes at this spot as well, don't you? So it is 70 minutes. Now, another way to think this through as well. Suppose 10 minutes, 20, 30, 40, 50, 60, 70. And you said, well, suppose I just walk the dog for 10 minutes. That's going to cost $5. It's then $2 after each 10-minute session after that. So you got 7, 9, 11, 13, 15, and 17. Notice it's at the 70-minute mark that you get that. So you could try to set it up algebraically. Just notice that you sometimes lose meaning of what it represents. Or you could just do the problem. If you don't know how to do the problem, just do the problem, if you get my point. So algebraic expression. Given x is 3 and y is -2, determine this. Be ready to perform order of operations and deal with negative exponents. See if you can do that one on your own. Bless you. Almost seemed like you tried to hold that sneeze back. Common thing in this classroom for people to hold their sneezes back.
Only 2 of us.
Though the rumor is it can be unhealthy.
Over break, I did sneeze once without holding it, and nothing came out.
But it scared the heck out of you, didn't it?
Oh, yeah.
I've got -6 on top. On the bottom, I've got 9 plus 8, and then I have a plus 2 on the end. So I have -6 over 17 plus 2. I chose to write that as a improper fraction. So I created common denominators. -6 over 17 plus 34 over 17. I got 28 17ths. 28 17ths. which is what Maggie got, so I'm assuming I'm right. If the whole test was about simplifying algebraic expressions, many of you would get an A+, but it's not all on that. If you're adding algebraic expressions, simply combine like terms. Negative z and negative 4z make negative 5z. Positive 1 and positive 1 make positive 2. What do I do if I'm doing subtraction and not addition?
Distribute the negative sign.
Distribute the subtraction sign through. Very good. I have 3w minus 4y. And as I distribute that subtraction sign, I get a minus y and a plus 2w. 3w and 2w make 5w. And negative 4y and negative y make negative 5y. Try the next one on your own. Share with the person next to you what your answer is. I hope we got 9x squared and 4y squared. We are also going to add in the middle a negative 12xy when you FOIL this out. Make sure that you multiply both pieces. I don't often see an addition problem on the ACT, but I've seen many examples in the practice test of subtraction and then this type of multiplication. As you move towards the top, we're not going to do this problem all the way through, but let's just talk about what you would do. You take that 2x times each part, and you take that negative 1 times each part, and you would combine like terms. Right? What if you see division? What are you going to do if you see division? You going to quit?
Divide.
Divide how? Synthetic division. What number are we going to put out front? 1. You're going to make that half box. What are the numbers that go across the top?
1, 0, and 4.
Good. Why the 0?
Placeholder.
Placeholder for the 0x squared. I go ahead and I drop this 1 and then I multiply. 1 times 1 is 1. I add and I get 1. 1 times 1 is 1. Add and I get negative 3. 1 times negative 3 is negative 3. Add and I get 0. So it looks like we would have x squared plus x minus 3 is our result. The ACT loves to give problems involving exponents. I promise you'll see that. Try these next two on your own. See if we get the exponents. Your first one is you take this 2x, you multiply it by whatever that next piece is to the 4th power. We get 81 x to the 4th, y to the 8th. Now you multiply, you should have 162 x to the 5th, y to the 8th. The next one, 10 over 15 reduces to 2 over 3. And if you notice, you have negative exponent there, bring it up top, you get a y to the 10th in the top. The ACT also loves to show you inequalities. In this inequality, you're going to distribute the subtraction sign, or the negative, excuse me, you get a negative 3 plus x plus 2 is greater than or equal to 2x minus 4. I'm going to combine my negative 3 and my positive 2 to make negative 1 greater than or equal to 2x minus 4. I'm going to gather the 2x on the other side by subtracting 2x. I get negative x minus 1 is greater or equal to negative 4. I add 1 to both sides, and I get negative 1 is greater than or equal to negative 3. As I divide by the negative, what do you have to do? Switch the sign, okay? So you mark 3, close circle due to the equal piece, and x is less than, so arrow goes back this way. So expect to see the answer possibly expressed in either inequality or as a graph. I don't really see them use interval notation, so I don't think you need to worry about that. We're not going to completely solve the next one. We're going to talk about it. I don't like the fractions, so what would you do to get rid of the fractions? What number do 3, 2, and 5 all divide into evenly? 30. So I'm going to multiply through by 30. And notice as I do, I have 30 divided by 3 is 10. And 10 times 2x is 20x. 30 times 1/2 is 15. 30 times 4 is 120. And 30 divided by 5 is 6. Once it's sat in that situation, would you then be able to solve it? Yeah, take an opportunity to get rid of fractions by multiplying through by a number. It should work out quite well for you. Still in the algebra and functions realm, it says determine slope graphically and algebraically. So as you look at this problem right here, we want to find the slope and the y-intercept and the x-intercept. You should be able to solve for y. I'll subtract 3x from both sides. And I will add 6 to both sides. And notice I have a negative 2y, I have a negative 3x, and I have a positive 6. Now I choose to divide through by negative 2. And I have y is equal to 3/2 x minus 3. So you can see that the slope is 3/2. And the y-intercept is negative 3. I know you all know how to do that very well. However, I don't know if you remember, how is it that we find the x-intercept? We set what equal to what? Y equal to 0. Notice if you set y equal to 0, you get 3x minus 6 is 0. If you were to solve that, what would you come up with? 2. So you can see that your x-intercept is 2. Flip it over, just have a couple more problems we're going to look at and we'll be done. I have that equation, y is equal to 3/2 x, was it a minus 3? Is that what we had? Okay, we want to write an equation for a line that's parallel to that passes through 6, negative 2. What two things do you have to have in order to write an equation for a line? Slope and a y-intercept, or we're going to use a point. I'll use 6, negative 2. And if it's parallel, what is the slope going to be?
6.
Yep, 3/2. As we write the equation for the line, remember it's y minus y sub 1 is equal to m times x minus x sub 1. So that's a piece you should always keep in mind and remember. So this is going to be y minus 2 or plus 2? Plus 2 is equal to 3/2 times x minus 6. As I distribute that 3/2, I get y plus 2 is equal to 3/2 x. And when I multiply 3/2 by 6, 3 times 6 is 18, divided by 2 is 9. I have 8 minus 9. Subtract that 2 and we get y is equal to 3/2 x minus 11. Let's not work out the entire problem here, but let's just set it up. The point remains the same. It's passing through 6, negative 2. But now it says that it is perpendicular. What do we then know about the slope?
Reciprocal and opposite.
Opposite reciprocal, negative 2/3, and you could do the same piece there. So we will continue picking up with this tomorrow. We have more things such as quadratics, function notation. Eventually, I think that tomorrow we may get to, will we get there? Probably not, maybe. But eventually we'll get to the geometry point, and then obviously we'll get to the statistics and probability piece as well. 3 days we should be able to knock this out and then give you guys some real time in class, be able to practice these and go over some of the answers together. And but good job, but be ready to do that moving forward.